Okay.
Occupations.
Okay, so where's the glare that I shouldn't write on?
It's right
Oh.
there. Yeah, see it's
Literally just go up and like circle it with the marker and just write the word in the circle.
right there. Is that
So Miss Avizo.
Well, it changes on your,
Okay.
your viewpoint.
Yeah, because if I stand up, it goes higher.
Miss Avizo, if you take some.
Okay, so
take some
Ty, look
textbooks,
right there.
If you take some
So
textbooks.
where is it? Like right here?
Yep, it's right on your hand.
Does that seem like if I don't draw on that X?
I can't like see the X though, so I
So
think that's good.
Okay, so don't let me erase this X today, and hopefully that will help out Faith. Okay, so rule number 1. Okay, when we assign oxidation numbers is if it's an element, it equals 0. So if it's just an element all by itself, even if it's diatomic, because that's its natural state, its oxidation number is 0. Yeah, so natural elements equal 0. Okay?
Oh, we had a whole like acid.
Yeah, this was chapter 4, and the D, I'm going to go over, like, I'm simplifying them in my, how I think about them. In chapter 4, like, the official breakdown of all these rules. But, okay, rule number 2 is if it's an ion, the oxidation number equals its charge. So if it's an ion, if it's a +2, then its oxidation number is +2. Okay, rule number 3 is if you add up the oxidation numbers, so the sum of all of them in a compound should equal the overall charge. Okay, so the sum, if I write these really simple, if it's too simple, let me know and I can add more words. But the sum of the oxidation numbers, I guess sum of a compound, we'll say that, should equal the charge. So if it's neutral, they should add up to 0, but if it's something different, it should add up to that charge. Okay? I wrote my rules like this since there wasn't very much space, so I'm going to go over here for number 4, in case that helps you. Okay? If it's in group 1, where's group 1? What's a group? Column, right? So hydrogen's family, but hydrogen's not in that family, right? He's adopted. Okay? Group 1 equals +1. Group 2 equals +2. Whoops. Okay. Next rule, oxygen. Do you remember what oxygen usually is? -2. This is one of our soft rules, right? That's why it has the word usually in there. This is a hard rule, this is a soft rule. Oxygen is usually -2. Just anyone remember the exception?
Hydrogen is 1.
Close. Peroxide, but normally hydrogen peroxide, right? So except peroxide is -1. Okay? Next rule, hydrogen is one of 2 options. Hydrogen is +1 if it's with a non-metal, and -1 when it's with metals. So depending on what hydrogen is bonded with, helps you know what its oxidation number is. And then our last rule is, well, that's weird, 7. Fluorine. Oh, I can never spell fluorine. Just the L too close.
Just do F.
Fluorine is -1. And the other halogen, so the rest of its family, are usually -1. Okay, I know these seem like a lot, but the more you use them, like the more the natural they'll feel. Okay, so let's look at that practice problem below and practice assigning oxidation numbers. Okay, does everyone have the rules down if I erase them now?
Yeah.
Okay.
Don't erase the
Don't
X.
erase it.
Oh, you scared me.
You erased part of the X.
Like what? No, I promise not to erase it. Okay, so I'm going to do the first one, and then you'll do the second one for some smiley faces. So I just go from left to right and I follow the rules. So cadmium,
Where's C?
all by itself, it's just an element.
Oh, so
Yes.
0.
Oh, sorry.
And remember, the way I like to do it is oxidation numbers I always write below, just so I don't think it's like a charge. Yeah, Nikki.
What about diatomic?
So diatomic would still be 0 because that's their natural state.
Okay, so then if it wasn't in its natural state,
If it wasn't in its natural state, it would be something different, but then it'd probably have a charge on it, which tells you its oxidation number. Because otherwise you wouldn't be able to, like, know.
so then why is like O2 different? Because isn't that part of the mix?
So, are you talking about like how the rule oxygen is -2? That's referring to when it's in with other things. So like in this next one right here, Nikki, so since oxygen is with nickel, right now its oxidation number is a -2. Because it's not a natural element, it's a compound, and the rule for oxygen is -2. Did that answer your question? Okay. Now, do we have a rule for nickel?
No, but it's gonna
It
be
would just
0,
be
right?
No. But we need the whole compound to equal its charge, which is 0. So now this is where you have to be careful. The oxidation number for oxygen is -2. So we have 2 of them, so total -4. So sometimes if you want to keep track of totals underneath, but keep in mind if it said what's the oxidation number, the answer is -2. The answer is not -4, that's the total. So that means the oxidation number for nickel must be, there we go, good job. Okay, pause me if you need me to. All right, coming to water. Oxygen is -2. Hydrogen,
Wait, what about the 2? Wouldn't it make
It's +1. Oh wait.
It's
Plus
still.
so
Oh,
it's
yeah, +1.
+1, which you can see it still adds up to 0, right? Because you have 2 hydrogens, 1 oxygen. Good? Okay, continuing onward. All right, oxygen is -2.
Wait, isn't that peroxide?
No, peroxide is only, it's O2 with a -2 charge. That's what peroxide is. Pretty much you'll know it's peroxide because it won't work out to be 0.
What's the OH then? Like OH minus. What is that again?
Hydroxide.
Hydroxide.
There, yeah, similar technique. So this is -2. Hydrogen's going to be +1. Now we got to do some math for our cadmium. So -2 + 1, those together add up to -1. We have 2 of them.
Minus 2.
So cadmium's going to be +2. Okay, same thing, -2 + 1. It's actually the same exact setup, so nickel here would be +2. Now we assign all of our oxidation numbers. Now the reason why we did that is so we can see what is losing electrons and what is gaining electrons. So now we take our pen and we see what changes. So cadmium goes from a 0 to a +2 charge. Which are other, so what's the other thing that's changed? Nickel, good. So nickel goes from a +4, oh, too far, to a +2. I know, I'm worried about that X. Okay? Now, which one's being oxidized and which one's being reduced?
Cadmium's being reduced.
CD's oxidant. Oh wait, no, CD's reduced.
You read it the first time.
It's reduction.
Because if I lose
Oh,
electrons,
yeah, I got it.
your charge gets more positive. And
Oh.
if I gain electrons, our charge will get more negative. The way that actually makes the most sense to me is, what does the word reduction mean?
It just says reduce, so if you want to go from like 4 to 2.
If you're going down, it's always being reduced. So then we label this as a reduction. Now another way to check yourself is you have to have both. If you finish and you have 2 things being oxidized, you've done something wrong.
Done messed up.
Yeah, it won't work out. Or even if you have like 2 oxidizing and 1 reduced, like you just have one and the other and everything else stays the same. Okay, do we feel like we could try the second one for some smileys?
Yes.
Okay, let's try it.
Smileys.
Oh, I think there's a typo on yours. Yes. Yours says H2. It's supposed to be H2O2. Cross that off. Yeah, way important. I did it the first time. I was like, this is broken. Yeah, it didn't work. But change it to H2O2 and then it will work. Okay, try it out. I'll give you 2 minutes. So label your oxidation numbers.
For 2BR,
Do I dare to give you a smiley face for every oxidation number?
Sure.
1, 2, 3, 4, 5, 6, 7. Plus, if you get oxidation and reduction, so 8 smiley faces.
As long as you give B7 a chance.
No, don't give them a chance.
As long as I don't give me some.
No, we do give
Wait a
them.
minute.
Wait. So right here, where's this 2H? Where's this 2H plus? Is that the same thing as H plus? So do we like write that in? Wait.
No, so it's just
For
H plus.
H2O2?
Okay.
So if it's just an
Okay,
ion,
is it H2O2?
then the oxidation number is the charge. So it's just a plus.
Does H2O2 have a charge?
As a whole,
It doesn't.
it's neutral.
It's neutral. Okay, good.
The name of this compound, by the way, is hydrogen peroxide.
Oh.
Okay.
Thanks.
Oh, that's
Oh, wait, that's
O2
peroxide.
And once again, if you don't treat it as peroxide, you should see that it doesn't really work out,
Yeah, I know.
right? So it's kind of a nice trick with peroxide.
If you didn't call it a peroxide, though, I would not.
You can't. It has to be plus one.
Just know with oxygen Quentin, if the numbers aren't working,
It's gotta be peroxide.
it's probably peroxide. Because you know hydrogen can't be anything but a 1, right?
Yeah.
And if I try to put this as a -2, it doesn't work.
So for like the H plus and BR minus, are those still 0 or are those like a dash?
Wait a minute. So not all of these are gonna be oxidized with dudes, right? Some of them may like. Yeah.
Let's try one.
And also for
I'm guessing it's still 0 because
it
the
has to
only
be just
thing.
one. The moles in front of it is not.
The moles in front don't mean anything, actually. But the thing is,
Because H will change
this falls into
to
mole number
be
2. Those are ions.
So that would be the.
Its oxidation number is its charge.
Right. But wait. But don't these rules kind of like fight each other?
No, because an ion is not classified as a charge.
Oh, it is.
Classified as a minus. Yeah.
Okay, so you said what's the
Well,
Because peroxide has there's 2 oxygens. It has a -2 charge. So this is peroxide.
and then
Oh, yeah, 'cause this one. Oh, so if it's getting the highest number, then it's negative
Is BR 0 or is it negative 1?
So in the original,
bromine
so,
too.
but 2 bromide minus is an ion, because it's charged.
Yeah.
So it would be -1, the total would be -2.
Well, it's 2 BR, like the coefficient has nothing to do with it, does it?
It does, because the 2 is observed times its charge.
Because we were right, BR
we didn't do anything on
2H2O we didn't.
And it's going to 0.
2H2O.
But they
But it's still plus or minus
-2
2.
charge.
Yeah, we
Would it be
did.
-2 by that?
Coefficient here is still plus or minus.
Honestly, the most common peroxide you're going to see is that hydrogen.
So,
Yeah, one
BR
second.
minus is just an element, but it's charged, so do we go off the charge?
Yeah, because technically when something's an ion, we don't really say it. It's still an element, but it's not its natural state.
Alright, so BR2, is that, it's not alone because there's 2 BR.
Good, but is that how it naturally exists?
Yeah.
BR normally BR2?
No, it's not.
Okay, BR changes.
Oh wait, yeah, it is. Yeah. So it would be 0.
smiley face for everyone.
Wait.
Stop me if you don't understand, okay? All right, this should be -1.
Yeah.
This should be -1. This should be +1. Okay, this should be +1. This should be 0. This should be -1. 2. I wrote 2. I said 1. This should be +1. Okay. You then should have identified that bromine is being oxidized, and oxygen is being reduced.
Because places for like oxidation.
Yep, so up to 9 smiley faces if everything's
The reason H+ is being left alone is because there's a +2 on this side and then a +2 on that side. Well, even
It's
like
the individual numbers, right? It's +1, it's still +1, it's still +1,
okay, yeah.
so it doesn't
So like
change.
the moles in front of it wouldn't factor if as long as it's just all +1.
Yeah, really, with oxidation numbers, you don't have to look at the moles at all.
Okay, so how many smiley faces?
So 9 if everything's correct.
9.
Okay, next piece to our puzzle now. Oh, I erased the X.
Dang it. Do we need to remind you every single time?
Possibly. Hey, but how often do I have to remind you guys? Okay, this right here, you have to, I think I even printed it on your paper. It's also in your note packet. The next big thing we're going to learn today is balancing redox reactions. Yeah, Brecken.
Sorry. For the problem that we just did, why was the H2O2 +1 and -1?
Because it was hydrogen peroxide.
Okay.
And if you kind of think of it as like, if you tried to assign, so if you tried to assign this as -2, like normally, right? We'd run into an issue. Because now this equals -4, but the rule for hydrogen is what? It has to be +1, so it doesn't work out. So it's kind of like if you get stuck with oxygen, it's probably in its peroxide form, because normally the math just gets stuck. So, does that make sense? Jordan?
I think your camera battery died.
No lights blinking.
Oh, it's good. Thank you,
Oh,
though.
it's
Yeah.
good.
Did it make a
It's just
sound?
a black
No, it's
screen.
just a black screen.
Oh, it just goes black, but I can see it's flashing.
Okay.
But thank you. It actually came back to life. I checked the battery this morning and it had 1 bar, but now it has 3, so I don't know what that means. So that's a good sign. Maybe it's because we're talking about batteries or something. I don't know. Okay, so as we learn this, everyone, I'm going to tell you right now that this is a little bit of a lengthy process the first few times that you do it. But like other things we've done in the class, the more you repeat it, you should get faster and it's not as intimidating. But I'm going to tell you right now that the first time we walk through this is going to be like, whoa, that's a lot. I'm also going to be using different colors for every step. So if you want to do the same so that when you go back and look at your notes, you can follow it, might be helpful. Okay? Pretty much what we're doing when we balance a redox reaction, okay, is think of it kind of like we're working backwards. Where this reaction right here simply just shows what's being oxidized and what's being reduced. In a sense, it's kind of like the net. It's the main theme. When we balance redox reactions, we're working backwards to get the full overall. Okay? All right, so step number 1, if you look at your steps on your paper, what does step number 1 say we need to do? Okay, so we're going to look at this when we do redox. Sometimes the simplest way is to look at each part separately. So look at just the oxidation by itself and just the reduction by itself. So I'm doing this step in orange. Okay? Pretty much to separate, you just look at the common species and put them in one equation. So I'm going to take this. I'm going to have MnO4 minus is changing into Mn2 plus. There's 1/2 reaction. Second half reaction would be C2O42 minus changing into CO2.
Oh, there's.
Okay, so just split the reaction up based on the common elements of those things.
Oh my, I don't.
Do they need these font lights?
Yeah, because we're going to add things to them, so don't write them too close to each other. Because you got to remember, we're like expanding these equations. Our end answer is going to be big. Okay? All right, what does step number 2 say to do?
Balance each half reaction.
Okay, so now we're going to balance each half reaction separately, and then we'll bring them back together. So 2A says what?
Balance elements other than H and O.
Okay, so we're going to look at everything besides hydrogen and oxygen and balance those first. So in this equation, there's 1 Mn, good, balanced. This one, we have 2 carbons. So I need to put a 2, so I'm doing this step in pink. So 2A is in pink.
I'm doing different.
That's fine, I'm just labeling
Oh
mine.
wait, you're doing like 2 A's.
So like, yeah, like, it's like gonna be a rainbow. Like, see my paper when we're done? It's a rainbow. Okay,
But there's 5 steps.
okay, not a full rainbow, but you know. Okay, good on that step? Okay, step 3 says, next balance oxygen atoms by adding water. So one of the things that gets removed is the water that the solution is in. But we're bringing that in to see how it all balances. Okay? All right, let's do this one in black. Okay, so 2B, we're balancing the oxygens with water. So in this equation right here, I have 4 oxygens on the left. So I need 4 oxygens on the right. So that means I'm going to add 4 H2Os
Oh, because it's 4 oxygen.
to make the oxygens balance, because that's what I'm focused on right now. Okay? In this reaction right here, do I need to add any waters? Nope, because the oxygens, 4 O's, since I added that too, there's actually 4 O's, we're good. Okay? All right, step 2C says,
Balance each atoms by adding each plus.
so the thing about redox reactions is they can be performed in an acidic solution or in a basic solution. If a solution is acidic, what does that mean is floating around in that solution? H pluses. So that's why I can just add them in, because they're actually already there. We're just trying to see the ratio. So in this reaction, I have 8 hydrogens on the right. So I'm going to add 8 H pluses to the left to balance out the hydrogens. This side has no hydrogens, so we're good. Okay? All right, 2D says,
We don't need to add H2O on that side?
Adding electrons.
no, yes, we didn't have to add water because the O's were good. And if you don't have to add water, then you typically won't have to add H's. So, okay, 2D says what?
Add electrons.
So now we're looking at, okay, how many electrons are being transferred? So what we're going to do is we're going to add up the charge on each side. So the total charge of the reactants, we have 8 positives, 1 negative, so plus 7.
We're adding the charges?
To see the electrons. On the on the product side, I have plus 2